All very welcome to this morning's CPD event with Aereco Ireland. We are just going to give maybe another minute there before we get started. We'll start exactly on 11 o'clock. So there's lots of people coming in, but look, I'll plow on a little bit there with some housekeeping from the association, but people joining in. So first of all, obviously our first event of the autumn. We're a little bit behind schedule with it, but we had something lined up for thermal bridging, which didn't quite happen, which we'll do later in the year. So we're delighted to move on to the topic of ventilation this morning. Behind the scenes, we have been very busy as a committee. We have had our usual meetings and dealing with assessor issues that have come in and putting questions to SEAI and dealing with such issues as, we had a lot of people contacting us around the whole idea of the value of the work of assessors. And we have a new article that was in our newsletter and published on our website this month, which deals with that. So we have been working away on feedback from assessors in the background. We've also had our recent meetings with SEI, which have been, mainly dealing with, there's a changeover of program manager there in SEI. So, we'd like to extend our great thanks to Dara Stewart and all the collaboration we've had over the years with her. And she was fantastic. And welcome Katrina Fitzgerald, the new program manager. I'm not quite sure what her title is. She might be on the call. She might send it into the chat there if she let us know. So welcome her to the role, and we really look forward to working with her on all the developments that are upcoming in the near future. The Energy Performance of Building Directive, the rescaling of the BR, the Building Passport, new initiatives as they come in on the grant schemes and traditional building professional role, etc. We've a lot to be getting into. We've also been sitting on a steering committee that has been organised with SEI, Building Control, IGBC and IES on approaches to dealing with the non-domestic building passport. So the committee has been sitting in on that. So it's very much a starting point. So not much really solid to report on it yet, but interesting to see the directions they're thinking of going. We also have got more scheduled upcoming CPD events, and we'll be sending out notices in due course of how to register for them. But you can put on the first Tuesday in November, I think it's the 4th, we have EnergyWise are going to be presenting on PV, looking into the whole workings of PV and, talking about new developments in it and maybe things that aren't quite picked up in our deep software, around shading and the new technologies and stuff that are invented, just to give us all as an assessor community a good understanding of how it's working and what the future of that's looking like. And then we have some more lined up on natural materials towards the end of the year. We are speaking with a heat pump company about going back to heat pumps and they're working. And also we have that CPD on thermal bridging that we hope to get back to. So that will be coming. Watch out for the newsletters. You'll see all them topics coming through. And as always, feedback from the association members, any suggestions, topics, speakers that you would recommend, we'd love to get that and on that. And on engagement, I really want to put out a call again to arms really here. We have, we've up on 200 joining us this morning, and we'd like to put a shout out to, we need more committee members. We need more help on the committee. It's not a massive undertaking, we'll have about 10 meetings a year that takes an hour or two per month to deal with that. And if you have a special interest in some topic you'd like to champion and work on, it's a fantastic way to do it. Anyone that has any experience in governance of associations and things, we'd love to hear. We need to sort out our own governance and get our own house in order, so we'd love some special advice on that. And I would say, most people I talk to, they say they're too busy for it. But I mean, I would say to you, you can't be too busy for this. This is what's keeping you busy. If you want to stay busy, join the committee and make sure that we're representing the association voice at high levels to make sure that we're properly represented. Last bit of housekeeping on this is CPD certs for today's event will be sent out. We'll send the list to the guys in Aereco and they will send them out. Barbara has informed me that there is a lot of people on the call who don't have their second name. If you could add your second name to your profile, it makes things a lot easier for us to to sort out all the names that we pass on. And if for any reason you don't end up getting the cert or you think something's wrong, email admin@BR Assessors Association, and Barbara will sort out that for you if you don't get your cert in due course. And yeah, that's the email as well. Anything to do with committee or anything like that you want to contact us with, either directly to myself, chair@BR Assessors Association, or admin will end up on Barbara's desk and she can forward it on to me. Right. So that's enough of that. On to today's event. We're delighted to have Aereco Ireland, one of Ireland's leading ventilation companies that I've personally been working with and dealing with for years. A fantastic organisation, and we have two very experienced people carrying out this CPD for us event this morning. And first we have Colin Foley, who's Technical Director at Aereco Limited. He's a background in M&E consultancy and engineering for over 12 years, both in Dublin and Cork. He was involved in the design of numerous projects in commercial and residential, both mechanical and electrical services, such as the Harcourt Street Hospital development, Mahon Point Shopping Centre, Riverlea Hotel and leisure centres, and numerous housing and apartment developments throughout Ireland. He's been with Aereco since 2010, a high-level understanding of the Irish building regulations and Part F, and was involved in Aereco aggregate certification process from the outset set to completion. I'm saying that was a pretty tedious undertaking. Member of the NSAI technical group on ventilation for buildings. And Tony McMahon has even more experience, 20 years in the ventilation industry, specialised 32 years of experience there between us. Specialising in mechanical ventilation with heat recovery systems, indoor air quality and sustainable building technologies. Since he joined Aereco as project manager, he's focused on growing the company's market presence, supporting engineers and installers nationwide, and promoting the health and energy benefits of effective ventilation in Irish homes. He began with a background in mechanical engineering and involved through hands-on roles in sales and distribution and business development over the 20 years. He has helped introduce and grow leading European brands such as Orkan, Zender, Brink and Ubink in Ireland, always with a focus on technical excellence and customer partnership. As a founding member and chair of the Residential Ventilation Association of Ireland and a board member of Passive House Ireland. So a wealth of experience there, gentlemen. So I feel we're in great hands to hand over to you. I think you're going to go first, Colin, right?
Yes, good morning. Sorry, just find this.
That's great. We can.
So good morning.
Yeah, perfect.
Right, so you're saying is okay. Good morning, everyone. This is a CPD presented by Aereco Limited. Sorry, just. Okay, Aereco Limited, which is part of the Aldays Group, develops innovative ventilation solutions for residential and office buildings with a key concept: the modulation of airflow rates according to the needs. So several lines of products can be implemented in various systems, from natural and hybrid ventilation to DCV, MEV and MVHR. So Aereco SAS is based in Paris in France, invented the modern humidity controlled ventilation and has been the market leader in demand controlled ventilation for dwellings in Europe for over 40 years. So Aereco Limited are currently the only Agreement certified demand controlled ventilation system to meet Irish Part F building regulations. So this agreement applies to all our demand controlled ventilation extract systems, provides a unique pathway for our constant pressure systems to be validated under the NSAI scheme. So I suppose we focus primarily on demand controlled ventilation and MVHR, but we also do a passive stack ventilation systems, exhaust air heat pumps with hot water, and we have a range of commercial air handling products, which we will touch on very, very briefly. So why do we need ventilation? So we spend 90% of our time indoors, and indoor air can be up to 50 times more polluted than outside air. So indoor sources of pollution include odor, moisture, particulates, VOCs, ozone, bacteria, and CO2. And then you have external sources of pollution, which we're all familiar with. Again, radon, moisture, external emissions from vehicles, pollen, agricultural pollution, etc. Sorry. So we'll focus mostly on moisture prevention or moisture control. You'd be surprised how much moisture is generated by an average family of 4. So even just by sleeping, a family of 4 will produce 2 liters of water per day. Bathing and showering, 1.5 liters. Cooking, up to 4 liters. Washing clothes, 1 liter. An unvented tumble dryer can produce 5 liters of moisture, and other activities 3 liters. So you're talking 16 liters of moisture being produced each day by an average family of 4. So there are different systems for ventilation. You're probably all familiar with natural ventilation with intermittent extract fans, and background ventilators would traditionally be the most common method of ventilation in dwellings historically in Ireland. So what does it mean? It means there are intermittent fans which are on, normally linked to a light switch. Some have timers on them. They're turned on and off as used. So you rely on a large amount of background ventilation. The current building regulation stage, you need 42,000 millimeters squared of background ventilation for a 70 square meter house, and then initial 7,000 millimeters squared per 10 square meters above that. So natural ventilation is very dependent on the wind. So wind blows on one side of the house and it pulls air out the other side of the house. But in apartments where you have single facade apartments, you don't get that cross ventilation. So it can be an issue in apartments. So in apartments, you need high and low level ventilation. But there can be low flow rates because it depends on the wind. It can be noisy and has a tendency to be switched off. Normally there's an isolator outside the bathroom from fan maintenance, and people tend to switch them off because they can be noisy. So our system is called passive stack ventilation, or PSV. It's a low pressure ventilation system that relies on external forces, Mother Nature. So it relies on wind and temperature differentials to drive the ventilation. In Ireland, you tend to have low levels of ventilation with passive stack during the summer when the wind pressures are down and the temperature differentials are quite similar. And it tends to overventilate in the winter because, again, we experience high levels of wind. It's difficult to install correctly. It relies on the same technology that your standard chimney stack. So it's not very common in Ireland at the moment, but I suppose it has the advantage that there's no fan, so it's quiet, and there's no fan, so there's no electrical consumption from a fan. Then we have continuous mechanical extract ventilation, or MEV, or CMEV. So it's a continuous centralized mechanical system. I suppose it's solid and it works. There's a reduced background ventilation area in comparison to natural ventilation. It's 2,500 millimeters squared of background ventilation required per habitable space, but it also depends on the general ventilation rate. With fixed MEV, there's no modulation of airflow. It's set at the building regulations ventilation rates. It stays the same 24/7. You have background ventilators, but you don't have any control over those background ventilation. I suppose it can lead to excessive heat losses, as the ventilation rate is determined by the size of the dwelling primarily. But there are minimum extract rates and boost rates required, and it also requires considerable balancing at commissioning stage. So then I suppose we have the mechanical ventilation with heat recovery, which I suppose is the most energy efficient system because it recovers energy from the extract air to heat the incoming air. It provides good level of indoor air quality and provides filtered fresh air. I suppose it has the advantage for aesthetics that there's no background vents in walls or windows, but it must be designed correctly. There's a lot of focus on good quality design for MVHR, and dwellings should be as airtight as possible. I suppose it's more expensive than other systems, but again, it's relative. Again, same as the design, it needs to be installed correctly. A lot of experience of poorly installed MVHR systems over the years, but that is improving, thankfully. I suppose there's a higher primary energy consumption because there's 2 motors. Commissioning can be time consuming. There are filters that need to be changed and maintenance required, and it's ideally located within the heated envelope. There are other alternative systems also. Some of you might be familiar with what's known as push-pull or single room heat recovery systems. I suppose they have the advantage that there's no ducting required, but there are some questions about it in terms of its compliance with Part F, because as I say, it's a push and pull system, so it's only operating 50% of the time in each direction. Again, with Part F flow rates, they can be high in certain rooms, so they can be noisy, but the airflow rates are generally low. It wouldn't be considered a system, and it does require large wall openings, so typically 160 mil diameter in each room. There's also positive input ventilation. Again, its advantage, it's cheap. It's just a fan in the attic that blows air into the dwelling from the attic space. Again, it's not Part F compliant on its own. It's only considered an add-on to an already compliant ventilation system for new builds particularly. There's a lot of debate over this for the last 30 or 40 years, to be honest. There is a risk that by positively pressurizing the dwelling, you're pushing the moisture back into the fabric, which can have a risk of interstitial condensation. You've also increased heat losses because you're just blowing, I suppose in the wintertime, you're blowing cold air from the attic space normally into the landing of the dwelling, which can cool the building quite quickly. And there are filters to be changed in these systems also. So we'll focus primarily with Aereco on demand control ventilation. So what is demand control ventilation, or DCV? It's a way of looking at ventilation in buildings that's a little different. Instead of there being a fixed rate of air exchange for a building or room based on a best guess, demand control ventilation measures the air quality and adjusts the rate of air exchange minute by minute, room by room, based on actual need. So if you think about it, the quality of air in a building has less to do with its size or its number of bedrooms. It has more to do with how many people live there, what they do, what time to come home and go to work, take showers, and so on. So humidity is a very good indicator of air quality in dwellings. There are obvious issues like showering and cooking, but even breathing creates moisture and CO2. So by monitoring humidity, we can adjust the control and movement and volume of air exchange in a building based on the air quality. If humidity is not the best indicator, then we can use other things like presence detection or manual boosts. So by following the need of a building rather than a best guess, we also eliminate unnecessary ventilation, which in turn saves us energy. Then net result with DCV is a system that's comparable in efficiency to heat recovery, cost effective and simple, but most importantly, quietly monitors and manages air quality. So the principle of operation are 4 points really. There are air inlets, which supply fresh air to the rooms like bedrooms and living rooms based on occupancy. 2, we have extract units that take stale air away from wet rooms like bathrooms and kitchens as and when necessary. So the extract units are connected back to a central fan via ducts. So the fan is a control point. The quiet, constant pressure fan exhausts stale air out of the building. So it's cost-effective control of indoor air quality. Because the demand control ventilation, extract ventilation only needs ducting from wet rooms, it makes the system ideal for cost-effective installation of a whole house ventilation system. It's also ideal, therefore, for refurbishment and retrofit work. Both the inlets and extract units react to indoor air quality and adjust the rate of airflow. The fan detects these changes by pressure, which means minimal cables and no control wiring is required. It's just the flow rate accordingly. The fan is very quiet and very energy efficient, requires no filter changes, only minimal servicing, and should give you years of trouble-free running. So if you compare it to, say, fixed MEV, which is diagram top left, so you have a fixed ventilation rate, it's your standard MEV, which stays the same 24/7. But by adjusting the ventilation rate based on demand, we can reduce the ventilation rate when the buildings are unoccupied and increase it when demand is highest. So what is Part F? Part F is the actual building regulation, which is limiting the moisture content of the air within the building so that it does not contribute to condensation and mold growth. So it needs competent persons for design, installation, and commissioning. Minimum flow rates based on area or occupancy. Boost rates are required. There are exceptions in certain dwellings where the boost rate can be actually lower than the general rate. Part of 2019, there's an additional 25% fan capacity required for all ventilation systems, and fault indicators are also required. I suppose that's been the biggest change recently, I suppose, is each ventilation system has to be validated by independent third party. And the changes also have natural ventilation is only possible for dwellings with an air permeability rate between 3 and 5 meters cubed per hour. There are alternatives to systems that are in the guide. So you can read here how adoption of an approach other than outlined in the guidance is not precluded, provided that the relevant requirements of regulations are complied with. Those involved in the design and construction of a building may be required by the relevant building control authority to provide such evidence as is necessary to establish that the requirements of the building regulations are being complied with. So in Part D of the building regulations, it sets out certain criteria that have to be met. You can have a CE marking. There can be harmonized standards, which there aren't for ventilation. There's also a third option where you can apply an appropriate Irish standard or Irish agreement certificate, or with an alternative national technical specification of any state which is contracting party to the agreement of the European Economic Area. This is the important part, which provides in use an equivalent level of safety and suitability. So the best evidence to show that Part F is being met when covered outside of the content covered in the guidance document is by agreement certification. So I suppose we'll focus a bit on agreement certification because, as I said, Aereco is the only ventilation system that currently has agreement certification for Part F. Okay, so minimum ventilation flow rates are there for a reason. So with DCV, you're allowed to go below these ventilation rates, but the question is, if you go below these ventilation rates, does it comply? So quick summary of what the calculations are. So the general ventilation rate is based on occupancy, which is 5 litres plus 4 litres per person. So it's 25 litres per second for a 5-person dwelling. And there's also a calculation based on the floor area, which is 0.3 litres per second per meter squared of internal floor area. So 30 litres a second for a 100 square meter dwelling. Some calculations there on the top right. You can see a typical 115 square meter dwelling with a kitchen, utility, 2 bathrooms and WC. So the general extract rate would be 34.5 litres per second, which equates to 10.4 litres per second for a kitchen, 6.4 for utility and bathrooms, and 4.8 litres per second for a WC. But if you take those rates and you check the boost rate calculation, you can see that the general rate is 34.5 litres per second, but the boost rate is 43 litres per second. So what that means is you set your ventilation system, your extract rates for your kitchen and your en-suites and etc. at the rates given, but you also have to have a boost facility that increases the ventilation rate. So often people talk about 13 litres a second for a kitchen and 8 litres a second for a bathroom, but that's not exactly right. So just be aware that there are lower rates and higher rates based on the calculations that you must do. So to prove a system meets Part F1, there are certain routes for assigned certifiers or validators. So when claiming a variable volume system works safely, you need evidence to justify it comprehensively in the local context. So this is where the admin cert comes in. Stephen, you mentioned at the start that I was involved from the start to the end. Yes, quite tedious. It took 11 years from start to finish to get the system admin certified. So as it had to be agreed with all the interested parties. So we had to do a simulation of Irish dwellings, so typical building topology, local weather data, agreed occupancy scenarios, different levels of air tightness levels, and all had to be agreed with the relevant authorities. Safe thresholds of pollutants had to be agreed, so CO2 exposure, relative humidity, VOCs, etc. Then it had to be independently verified by a third party. It then had to go to building standards to make sure that they were happy that all the results were within their requirements, and then it was certified by the NSAI, who issued the Agreement Cert. So outside of the above, you have to trust the manufacturer's word. So the NSAI Agreement Cert was first awarded in February 2021. It's the first of its kind in Ireland, and it followed a commonly international approach. It only validates Aereco DC MEV to meet Part F1. So if it's DCV, only Aereco is currently certified for use to meet Part F. It covers all aspects of the ventilation system, so inlets, extracts, the installation, acoustic performance, the wiring, the commissioning, validation, fault indicators, fire safety, maintenance, and Part J in relation to combustion. Fault indicators, again, was introduced in Part F 2019. So all mechanical ventilation systems should be able to indicate that there's a fault. So that's true for centralized MEV and also MVHR. So control indicators should indicate to the occupant that the system is operating correctly and if a fault has occurred. So control indicators should be located in a visible location to the occupant and not in a remote location, such as in the attic or above the ceiling. So with our system, you have an extract unit that contains a sensor which tells the occupant if the system is operating correctly or not. So just to note that it has to be a physical device located in a visible location. An app on a phone does not suffice, and without this device, systems will not be able to comply, and validators will be, and do look for them. In terms of commissioning DCV, it's a very simple process. You measure the pressure at the extract units with a differential pressure meter, which is a manometer. You don't have to measure flow rates. So in terms of comparing to MEV, because DCV modulates the airflow, measuring the airflow only gives you a snapshot in time. So by confirming that the pressure is sufficient, we know that the ventilation rate will meet the demand. That's how you fill out the commissioning document. There's no balancing, and this reduces the time to commission and validate quite considerably. So at the moment, if you're measuring ventilation rates, you'd need a compensating pressure device for testing airflow rates, which are accurate but can be quite expensive, whereas pressure measurement is easier and more reliable indicator of DCV system performances. So validation has to be carried out in every home and has to be carried out by an independent certified person. So to validate system design and commissioning, only Aereco systems can be validated by pressure under the NSAI scheme. There are other schemes such as INAB, which are different, but the full procedure is outlined in the Aereco Agreement Certificate. Just to give you an example of what the validation or commissioning cert would look like, there's plenty of flexibility for after installation adjustments to facilitate commissioning and validation. Simple calculation of floor area to check the fan capacity, including the 25% spare capacity. There are no plus or minus margins for airflow rates or balancing of the system with DCV, and validation and commissioning effectively becomes an exercise in checking the pressures to say if it's over 60 PA, it's good. If not, it's not. So look, again, just touch on validators. Under the scheme, the validator has to be reassured that the performance he sees is consistent with the commissioning document and as per design. So he's not checking Part F compliance. He's just checking that what he's reading is consistent with what he's been given at the commissioning. So just to back up on on the whole system. A competent person has to design the system. A competent person install the system. So a competent person, the installer, to show competency, would have to carry out a course in ventilation installation and design, such as with the ETBs. And similarly, the person who commissions it has to be competent. And then the validator will verify that system performance meets the design, and the design certifier can sign off on compliance. So there's a chain between, I suppose, the end user and compliance with Part F. Lots of people are involved: main contractor, consultant engineers, design certifiers, installers, the commissioners, the designers, and like we've seen some manufacturers tend to use Part D of the building regulations to state that, just because an agreement cert has been issued in another country, that it complies with Part F in Ireland, which is not the true. So it has provided in use an equivalent level of safety and suitability, and it's the Irish building regulations, not a European building regulation. So we've seen people using a Spanish argument cert based on Spanish weather to show compliance with Part F in Ireland, which is not the case. So just make sure that if you are being asked the questions, that there is a link and there's no breaks in that chain. So if you don't have an argument cert, what do you do? So Part F requires minimum ventilation rates are always met by continuous MEV. So if the system goes below these minimum flow rates, what foundation of evidence is relied on that it can do so safely? There's one workaround, I suppose, with MEV or DCV, that you could set the ventilation rate that it's never below the minimum flow rate, but then it becomes an MEV system with a boost, and this has these additional losses. Use energy, and there's risks of periods of overventilation when you have a DCV system set up as an MEV at the minimum flow rates with an additional boost. I think I'll let Tony take over here. Tony, if you want to go on to the MVHR.
Yeah, okay, I'll give you a little bit of spiel about MVHR. What is MVHR? Most people know what MVHR is at this stage. It's mechanical ventilation with heat recovery. So it removes the moist, stale air within your home, taking air from kitchens, bathrooms, utilities, en-suites, office areas. So that warm air goes up, heats the heat exchanger, and pre-warms it, gets dumped outside. Fresh air comes in, filtered, recovers the temperature, and supplies tempered air back into the house. Yeah, so our heat recovery units are all kind of passive house certified, which, let's face it, a lot of people talk about passive and they talk about kind of building to passive, but in reality, lots of people don't actually go the whole passive route. They want the idea of passive, but they kind of see kind of passive products as a kind of a quality mark. So that's why passive house certification, I think, is kind of an important thing to look for on an MVHR unit particularly. So we kind of put systems together based on what the person wants and requires. So whether it's an Aldez, a Wolf, or an Exhausto unit, we kind of pick and match for the best system. So one of the important things about MVHR, and I keep saying this to people, is the importance of the air distribution system. And I keep using the analogy of it's kind of like putting you can put a mini exhaust onto I don't know, one of these big massive tractors, like, it'll just choke it. You can choke a ventilation system by incorrectly sizing your air distribution. And I come across it. It's probably one of the biggest problems I come across is people don't put enough ductwork into the system to allow the air to travel through the house with minimum resistance. And again, it's kind of like the same thing as architects. I'm constantly on to them. You know, if you give us the space, we can give you a very good system at minimum. You know, it reduces the cost because the outlay is less. You'll get shorter duct runs if you centrally locate your system. It'll perform better. It'll use less power. It'll be more efficient. It'll last longer. You know, the benefits are, you know, it's an ongoing benefit. The better you get a system in. I suppose what are the benefits of an MVHR system? Indoor air quality is probably one of the biggest benefits, because you're constantly supplying and extracting air at the same time, and because the incoming air is being filtered, you probably get the best indoor air quality in a house. And again, in the building regs, and from the point of view of third-party validation, building control would like you to slightly positively pressurize your house as opposed to negative. And that has the benefit of helping, particularly in renovations where radon barriers may not be installed correctly, and that you have slightly positive pressure. I'd be kind of more on the fence with a balanced system is your best system. So if you can exactly balance the system, then you have the best system, because you're neither pushing energy out nor drawing energy in. So you're maintaining the energy within the house for the maximum length of time. So if you have a balanced system, in my opinion, that's your best system. Unfortunately, the meters used to measure the systems aren't probably up to scratch. Most people are using the testometer from validation. They're relatively cheap, and I think that's why we're using them, whereas ideally we should all be using a pressure compensating anemometer, but I think that's coming down the road eventually with NSAI changing over. But I think the whole validation thing is probably not fully up to speed yet. There's a little bit of teething problems with it. I don't know if you guys come across them, but one of the things we pointed out to NSAI lately from the Ventilation Association point of view is the fact that there's no list of validators on the website anymore, which is very frustrating for anyone trying to get something validated. So there are teething problems that just need to be ironed out. I suppose I'll go through no, I think that's really all I need to say on that. Can you go on to the next slide, Colin, please? So we have this is a very nice machine that we use, the Inspire Side V2, which I think is particularly handy for renovations, because of its flat design. You can see it there. You couldn't have it with a hatch drop down into the, accessible from within the living area of the house. Very serviceable, like in that form. Difficult to get people to do that type of thing because it's not the norm. Most people try and throw them in the attics. And again, look, if it has to go in the attic, if it's the only option, it does state quite clearly in the building and regs that reasonable access should be made available to service the machine. So what is reasonable access? That's the kind of kicker on that part of the regs. That's open to interpretation, but climbing through a truss roof to me is not reasonable access, and not having a styra is not reasonable access. So unless you provide a reasonable access for an MVHR unit and you put it in an attic, that's incorrect. Also, MVHR units are designed to be put in within the thermal envelope of a home. And I know everyone says, well, they're insulated, they're made of polystyrene, but the losses and gains from an MVHR unit, in a cold attic are massive. I came across a guy there earlier on this year where I went to commission a system, and he had installed it in the attic. While I had agreed with him to allow him to install it in the attic, I had told him to create an insulated box for the machine to put it in his cold attic. And he'd forgotten to do that, of course. But as a result, he was blowing 27-degree air into his house. while the air outside was only 22 degrees. So that's quite a gain from just the heat in an attic alone. And it's a common thing that where we get it all the time is how am I going to cool my house down, and activating summer bypass. And to be honest, summer bypass is, in my opinion, a little bit of a marketing ploy. It works. It bypasses the air coming out of the house, so you're not heating it. But unfortunately, the volumes of air provided with your MVHR system are grossly insignificant, and incapable of cooling a house down. Based on 0.3 liters a second per square meter, your effect is absolutely minimal. So, if you've solar gain in a house and you try and cool it down with an MVHR unit, it's just not going to work. I had one guy in Sligo, I told him he'd need to put 4 MVHR units into his house on the ground floor alone to cool down the wall of glass he had. I mean, it absolutely ridiculous. So summer bypass is fine. If you're putting your MVHR in the attic, it needs to be insulated. You just can't leave it. Even though the machine itself has insulation around it, it's not sufficient ventilation to be put in a cold attic. MVHR units are designed to be installed. You'll see them in schematics all over the place, and they're in attics, but they're in warm attics in Europe, not cold attics that we have. Now, absolutely no problem, put them in warm attics in Ireland if you have a warm attic. If you don't have a warm attic, you need to insulate around the machine if you have to put it in an attic, and you have to give reasonable access to it. So, and it needs to be serviced. Again, people won't service them in the attics, You need to change the filters, check the filters every 3 months, which should be a relatively simple process. Just open the door and slide them out, hoover them. And by hoovering them, you reduce the effect of the filter. So that's why you change the filters. You can only hoover standard filter 3 times before it loses its effect. Then you need to replace them. So, and I find carbon build-up on filters is the biggest issue in Ireland, particularly in more built-up areas. But even in remote areas, I've seen it. Like the carbon is a big issue, and you don't realize it because we don't smell it, we don't see it. So changing filters is important if you're putting in a system. It's part of the benefits of the system. Main feature, the big advantage of that Inspire Air Side V2 is it's only 13 kilos weight. It's very compact, very quiet, and it performs very well. Very happy with that machine. Go on to the next slide, Colin. And we also have the Wolf machines, which is kind of more standard shape of machine for new builds and again renovations. They come in kind of sizes from 220 up to 600 cube, which unfortunately 600 cube machines are becoming more and more required. I always have this theory with building controls. We could build a lot more houses if we just built smaller houses. These big houses, these show houses, just that, maybe I'm just jealous, but I just don't see the need for them. So the Wolf machines, as you can see, that they are probably one of the more efficient. Again, they're passive house machines. They're one of the most efficient machines on the SAP. They perform very well. And again, I think it's important that, and I kind of welcome the idea from NSAI that they are going to start putting in the validation, the power consumption of the machine at validation, because unfortunately sizing MVHR machines, people are inclined to undersize them and put them at running at 75%, and then you're supposed to have 25% extra capacity. And there seems to be this trend now that there's the validation speed and then reduce it down to the normal speed, which is incorrect. I mean, the validation speed is your nominal flow rate. That is the speed the machine needs to run at 24/7. And that's the minimum. So building regs didn't come up with the minimum for you to go and reduce it. If you reduce below your minimum, you're not getting sufficient airflow to deal with air quality and moisture in the house. So it's, you know, you're kind of doing things a bit backwards, and you'll eventually suffer the consequences of it. All the Wolf machines they're all run on a constant volume fans, so they kind of self-balance. They're a very simple system to commission. They're probably one of the better ones that I've come across for commissioning. They're fairly quick, and they handle pressure quite well, which is a good benefit. Want to the next one column, please? This is just a kind of an Excel spreadsheet I use for calculating the size of machines, and it's just a kind of, I just want to show you this to indicate where the standard 13 liters from your kitchen and your 8 liters a second from your utility and bathroom and your 6 from your sanitary. And I've added one in there, an extra one. It's a small calculation for an office room. I extract there, I put a supply and extract into an office room because of VOCs from printers and computers. So since we've started to work from home, it's kind of, what I'm trying to do is give the homeowner the best indoor air quality into that office room where he's going to spend, well, he's supposed to be spending time not doing the dishes or the laundry, but, or he or she, or it. I'll get myself in trouble there, won't I? So as you can see, the 13, 8, and 6 on 184 square meter house, the minimum flow rate is 16.7 liters a second, which is a long way away from the 13 liters a second from your kitchen. And it's 10.3 from your bathroom and utility, and 7.7 from your WC. And that's the minimum flow rate. That needs to run at that 24/7. That's not kind of a boost flow rate. That's the minimum flow rate. Plus, you need an extra 25%. And then, as you can see down below, that table then divides your extract rate into your supply rates for you. So each living room area is kind of divided up proportionately to the extract rate. So you get a balanced system. Now I had this question with when they brought this out first, because I kind of felt that the living room didn't need 9.7 liters a second, because people don't spend a huge amount of time in the living room. They might watch a film, but they're kind of in and out during the day. Whereas I felt that bedroom 2 there at 5 liters a second, I would have preferred to be given it 8 liters a second. But apparently the research shows that the high levels of VOCs now that we have in our buildings, due to all the artificial products we put in and the glues and products we use in our buildings these days, in order to deal with these VOCs, we need, because of the bigger floor area, we need a much higher flow rate in those rooms, as opposed to, we'll say, the bedroom, which is smaller, even though it's occupied by a person. So that's the reason why we need such higher flow rates in the large living rooms and dining room areas. Because previous to 2009, you could just balance a system up, and I would have given the bedrooms more air than on the theory that people needed more air. Do you want to, is there another slide there? Yeah, and air distribution is the foundation of any ventilation system, in my opinion. You know, you get the foundation right, any system will work and perform correctly and work well. Without the air distribution correct, nothing is going to work. You're never going to get a good system. It's always going to be a problem. It's always going to be power hungry. It's going to be noisy. If you give the space to put in a proper air distribution, and if it's designed into the build, you know, good quality products. And again, it's very important that you have good connections onto the valve housings, onto the ceiling, because the house is built, the guy goes up, puts in cable, or runs in a satellite, or runs in broadband, and he pulls on a pipe and it disconnects, you know, and then it doesn't work. Where we've kind of tried and tested different systems over the years, and we find the system we have at the minute is probably one of the best, most robust systems on the market. And look, it's just the way Irish building is. It has to be robust. If you want something to work, it has to be robust, and it has to be able to perform even after the house is built. One of the things there is flexible duct, which often gets brought up on BR questions, you know, about There's flexible duct on the machine. Does that mean it's a flexible duct system? It's most MVHR units now use a flexible duct as an attenuator and just takes the fan noise out of the system. Now again, you'll notice there's a huge difference in flexible duct. There's everything from the kitchen extract type of stuff, white stuff that collapses in on itself and closes, to good quality flexible duct that I'd have absolutely no problem using and can actually perform every bit as good, if not better, than rigid, because you can create a 15-degree bend or a 30-degree bend as opposed to a 45 and a 90, which will create a lot more resistance than the flexible duct is going to give you. So again, it's the air distribution, I think, is critical in any ventilation system. Again, and I know nobody ever looks at it, you know, there are cheap, there's lots of people bringing in air distribution systems from different countries, and it is supposed to be listed on the SAP. If you're using an if you are using an MVHR system and using the semi-rigid manifold system, it should be listed on the SAP. If it's not listed on the SAP, then the machine needs to take the default value, which kind of is counterproductive in investing in a good quality machine that's high efficiency if you have to go to the default. So is there another slide there, Colin? Yeah, we also have the T-flow. Do you want to take that over, Colin, or do you want me to keep going on that?
I can, again, it's just a brief introduction of some other products we do. We're not going to spend too much time on it. It's just Aereco do a exhaust air heat pump with produces hot water with demand control ventilation. It's just we don't do a lot of it, but it's just, I'll just go through these quite quickly. It's just products that we have available on our as standard. So again, it's just an exhaust air heat pump that does ventilation and produces hot water via a heat pump. You see a lot of these around that would do heating and hot water. The one we do just does hot water only, so I won't spend too much time on it, to be honest. Again, it's quite big. It's handy for apartments, but the volume of hot water that it generates and the heat up times, it can be quite long. So it's suitable for apartments or very small houses. You wouldn't put it in your standard 4-bedroom semi. We also do a single room heat recovery system, which you might be familiar with. It's the push-pull. Again, we don't promote it as a ventilation solution. We would suggest it's for home offices, for garden rooms. As I said, they're an add-on. They'll do a bit of ventilation, but they're not a system. We don't sell them as a system. We only supply them for, as I said, for likes of a garden room or a home office. They tend to be too noisy, and people expect them to be an MVHR system, which they are not. Okay, we also do some commercial products, particularly for likes of schools. So we have decentralized MVHR unit suitable for classrooms, different models up to 1400 meters cube per hour. I'm not sure how familiar with Department of Education guidelines, but for schools and classrooms, noise is the biggest issue. So you see a lot of these on the market that can do the flow rate, but they're too noisy at that flow rate. So your standard classroom, you need quite a large volume of air, and to meet the guidelines from the department in terms of noise, they need to be generally oversized. So that's just an example of one. We also do some commercial small ceiling mounted air handling units. I'm familiar with it. It's just like a small air handler sits in the ceiling space, and we do up some large compact units as well, the Vex range. They're manufactured in Denmark by our sister company in the group, Exhausto. Okay, I suppose we'll focus more on maybe what you're asking about, or what you might be interested in. It's treatment of primarily Aereco, DCV, and MEV in deep. So when you're considering inputting DCV into your deep calculations, DCV must be treated as a fixed volume central whole house extract system. So the airflow modulation and reduced electrical consumption of the demand control ventilation fans, even though they're NSAI agreement certified, are not currently recognized in deep. What I mean is the advantages of the modulating airflow are not recognized in deep. So the Aereco humidity sensitive inlets are not included as passive vents because they can be closed to less than 3,500 millimeters squared. So the central extract fans run continuously are not considered intermittent fans. So you select the centralized mechanical electric ventilation option in your drop down. Recirculating hoods, which you often find in kitchens, you see a lot of these downdraft type extractors are becoming quite common. A lot of them will just recirculate and blow the air out at low level. Again, that would not be considered as an intermittent fan. Whereas if you have a kitchen, a cooker hood that's ducted to externally, then that is considered as a passive, an intermittent extract. So the system is classified as a centralized mechanical electric ventilation system or a whole house electric ventilation system, and the specific fan powers, or the SFPs, for the various fans are all listed on the PCD database. We provide this slide with the links. I'm sure you're all familiar with it anyway. So we have, some of you might be familiar with our V4A fan, and it's been replaced recently by the V4A2, which has better efficiencies and is also tested with semi-rigid ducting and results in a better energy rating. Again, the links are here. You're all familiar with that. You input your ventilation method, whole house extract ventilation. You put in your SFPs, your manufacturer, your model number, and then your N plus whatever is your kitchen plus X amount of wet rooms, and you should state whether it's rigid or semi-rigid ducting that's being used, or I suppose also flexible ducting. So for fan and ducting specifics for whole house extract systems without balanced ventilation, if a fan is not listed specifically for semi-rigid ducting, then the default SFP must be used. I know some people would state that for MEV, if the ducting is listed on PCDB for MVHR, that you can also use it for MEV. That's not the case. If you look at the BRE principle paper for the treatment of ventilation systems tested with semi-rigid duct type in the PCDB. So currently, again, this is on their website. The PCDB records whether the type of ducting is flexible or rigid ducting. So if a ventilation system is tested with semi-rigid duct type, then the semi-rigid duct must be stated in the model name or model qualifier. So the duct type chosen when the listing the system should be rigid ducting type in PCDB. So if you look at the PCDB, if you click on the centralized mechanical extract ventilation, you pick the brand name, you pick the model qualifier, and then if you drop down the menu, there should, if they're using semi-rigid ducting, there has to be two specific fans listed. So if you can see with the V4A2, it's listed for both 75 mil semi-rigid ducting and standard V4A2 premium is rigid ducting. So if you're selecting the fan, it should be there twice if they're using semi-rigid ducting. If not, if it's only listed once, then it means it's only tested with rigid ducting. So you have to use the default value for the specific fan power. So just as an example here, you can see the results for both the rigid and semi-rigid ducting for the V4A2. They're quite similar because with semi-rigid ducting, we recommend that 2 75 mil ducts are used per extract to reduce the pressure losses. But again, this is a specific BRE test. They would test with 2 pipes for the kitchen and a single pipe for each of the additional wet rooms. So you can see the results here. They're quite similar. So what happens when you're using multiple central fans? So for example, the V4A2 fan will do house up to 200 square meters, 4 wet rooms plus a WC. We often come across dwellings where you'd have your kitchen, utility, and your downstairs WC or bathroom are located centrally together, and then you may have 2 or 3 bathrooms upstairs. So in terms of efficiencies and cost, it often makes sense to put 2 fans in rather than trying to run all the ducting back up to a 1 central fan location. So for example, if you're using V4A2 extracting from 3 wet rooms, and you may have a second V4A2 upstairs in the attic, maybe doing the bathroom and the ensuite, what do? So you have to take the weighted average for the specific fan power. For example, here you have a V4A doing 3 wet rooms with a SFP of 0.16. The upstairs V4A2 is doing 2 wet rooms at SFP 0.17. So downstairs is doing 60%, upstairs is doing 40%. So you take your 6% of the 0.17, your 40% of the 6% of 1.16, 40% of 0.17, add them together, you get a specific fan power of 0.163, 64. So it's slightly higher. But if there's 2 fans doing the same number of wet rooms, then you would use the SFP of the figure given. So if they're both doing 2 wet rooms, 0.16 is kitchen plus 2, so that's your 0.16. So similarly for MVHR, similar in terms of the specific fan powers, but additional information regarding heat exchanger efficiency should be included, and you use the 2012 figure, not the 2009. So here's an example of the, again, it's listed on the PCDB. You pick your ventilation system, you pick your machine, your model qualifier, and if it's listed, it's there. It gives you your SFPs, gives your heat exchanger efficiency, and again, you state whether it's how many wet rooms are being used. So MVHR units are tested with using rigid duct only, but can you use SFPs if the semi-rigid duct is used? Again, you refer back to the PCDB. So if the semi-rigid ducting is tested and listed as equal to the rigid duct in terms of performance, then it can be. So only semi-rigid ducts that are listed can be used. Again, refer to the manufacturer's FP and their efficiencies in deep. So if you look on the right-hand side, it tells you what it is. So the purpose of the document is to define a technical specification for semi-rigid ducting systems connected to a balanced whole house mechanical ventilation systems with or without heat recovery, in order that it may be substituted for rigid ducting within the SAP calculations. So in order for this to be possible, individual semi-rigid ducting manufacturers or suppliers must demonstrate that their duct system, when installed in a variety of configurations, is at least equal in terms of aerodynamic performance to the rigid duct via an agreed third-party test. So again, if installers are using a semi-rigid ducting with MVHR, it must be listed specifically on the PCDB. And that's it for now. So happy to take any feedback, any questions.
Sorry, just trying to find my mic button there. A load of screens. I've been keeping track of questions coming in there.
Okay.
So yeah, that's fantastic. That is great. Great. And I think that last point on the ducting is, well worth reiterating and looking into. That last document you had up there was part F, wasn't it? Where you were taking that code from.
The very last slides?
Yeah, it was the arrow over to the left. That was in part F.
They're not in part F. They're on the PCDB. That's the BRE, or what we know as SAP Appendix Q. They're the principal papers they're on the PCDB. If you go into the PCDB database, you'll find some links. There's some technical questions, and there's the BRE principal papers. So you'll find them there. Again, I can supply the links. All the links are on the thing. I can send it on to you. You'll find them there.
Yeah, that would be great. We'll be sending out the presentation. Hopefully we can get the presentation off you as well, and then it will be on the members area of the association, so people can click into them and just look into that. I think it is very important. It's something we can getting the efficiencies right, but also for audit purposes that we can get pulled on that. So I'm not sure it's widely known enough.
It's a question. It's a question we get asked quite often, and I know that there are some people will say that if you're using MEV and the ducting is listed on SAP for MVHR, then it's fine. But you can see directly, it's a quote from the BRE. It's not. MVHR listed ducting is specific for MVHR systems only. It's not for MEV. They think MEV is a different. You have to test the system as a whole. You can't just test the fan. You have to test the system as a whole. So you have to have it listed separately if you're using semi-rigid ducting.
Good stuff. I'll go through a few questions there. We'll give it about 10 minutes or so, if that's okay. And if there's more questions coming in that we don't get answered, maybe we can put something on our newsletter or something later. I'll go through them, and I'll take a few now, and maybe John, if you could take note of a few if they continue coming in. So Owen asked about the slides. Yeah, we'll make the slides available with the presentation, with the guys' permission, of course, which I'm asking for live on air. Sorry about that. So we'll do that. Liam asks, is there a cost-benefit analysis for fitting MVHR in a deep retrofit? It's hard to sell sometimes to clients. Would it be good to see some data on real energy consumption, not just the effect on BR and savings from the heat recovery, even a case study in a deep retrofit? So yeah, is there a cost-benefit analysis on MVHR?
I suppose it depends on what you're comparing it to. Like we would have done studies, I suppose, traditionally we were a DCV only company, we only started doing MVHR maybe the last 10 years, I suppose, since 20 came along. So we would have had a lot of studies comparing DCV to MVHR. The savings were, sorry, I'm going to put my DCV hat on. When you consider I suppose the capital costs, the running costs, and the maintenance costs, the payback time was quite a long time comparing to, say, a good DCV system. But I don't have any data on MEV, and certainly don't have any data on natural ventilation, because natural ventilation is just, I don't even consider it anymore. It shouldn't be used. You still see it being used, and even though it's not supposed to be used only between 3 and 5, we have some evidence of air tightness tests coming below 3, and then they pop the attic hatch open to get it above 3 so that they can use natural ventilation. So I don't have answers in comparing it to MEV or natural ventilation, but look, certainly MVHR is the most energy efficient system out there by a long way.
Just what you're touching on there, Sarah had asked to reiterate that point on just exactly where Part F, what it does say about under 3, 3 to 4, and 3 to 5. You might just reiterate that. What is the rules in Part F with different air tightness requirements?
In terms of natural ventilation, they say that you can use natural ventilation, which is your intermittent fans and background vents, for an air permeability between 3 and 5. They don't state that you can't use it below 3. But what it does mention is that if you are using natural ventilation with an air tightness level lower than 3, then you must provide evidence that the ventilation, you're still meeting Part F1. So if you put natural ventilation in a house with an air permeability of 2.5, what evidence are you providing that by doing so, that you're still meeting the requirements of Part F1, which is limiting moisture and pollution? So there is no evidence, or how do you prove it? So it's, unless you have some studies.
That's why they've basically put it like that. You can't actually generally prove it. So basically below 3, you need to mechanically ventilate. That's, it's a simple solution. And to be honest, trying to measure between 3 and 5 and get something to fall into that category so that you can use natural ventilation and intermittent fans, it's a small window to try and achieve. So I for anyone building, I think they'd be better off to try and put in the best system and do a proper ventilation system and have it right, rather than hedge their bets on falling between 3 and 5. Everyone wants their air tightness. They want air tightness. They want insulation, they want to retain their heat. So they are generally building more airtight.
But it
There
was
was a bit of
they
a
they
back and
did
forth there on the how that this is new build we're talking about generally when we talk about these requirements. Am I right in saying, and I think there was also a clarification sought between maybe Eddie there as well, there isn't actually a requirement for retrofitting in ventilation in Part F. There's no set standard. No
There
set-
is
Go on, sorry.
there is an SR54, so anything with SEAI or deep retrofits needs to comply to Part F, Part 2019.
But there isn't an air tightness test mandatory, or is that only in the case where you do install a full mechanical ventilation, or is that just best practice?
No, you can install a mechanical ventilation system in any house, irrespective of its air tightness level. This kind of concept that you must be below 3 air changes an hour for a mechanical ventilation system to work is incorrect. It's just particularly for MVHR, you're not getting the maximum efficiency out of it because you have air leakage above 3, but they still perform and they still work and they still deliver, getting rid of your moisture and providing indoor air quality. And I think this is where people get hung up on too much, and they forget about the importance of the air quality in the house, and as opposed to the performance of what's happening. It's kind of, you're looking at the pennies, but you're not looking at the bigger picture. So like providing that I've installed an MVHR system in a 16th century folly up in Monaster Boyce, and that's not airtight, but without it, the walls weep and it's inhabitable, whereas the guy actually has it running on Airbnb. So, ventilation is primarily about the health and health of the occupants more so, and the dwelling, than the kind of energy rating of the house. And this is where I think SEI are even finding that, like, they focus so much on sustainable energy and reduction in costs and savings. They forget sometimes about the importance of ventilation. You have to have air.
Absolutely, yeah. I'll move on there. Mike, I think you answered Mike's question actually about since when are offices included in wet rooms for extract. I guess you're just saying that's best practice again, and what in your experience to get VOCs and improves ventilation rate.
Yep.
Thomas asked, do you have an agreement cert for your MVHR that complies with Part F?
MVHR is listed as a system in TGD, so it doesn't need an agreement cert. The agreement cert is only for a DCV system because the ventilation system under DCV can fall below the minimum flow rate. So any system that reduces the ventilation rate below the minimum, evidence must be provided that by doing so that you're not compromising air quality. So any system that maintains the minimum flow rate doesn't need that. If it's mentioned in Part F, you meet the minimum flow rates, you meet the boost rates, it doesn't need an agreement cert. It's only if you go below the minimum.
You see, you could modulate an MVHR system on a timer, and you used to do it before the new regs in Part F. And I think it's more applicable in colder climates where you have much more severe weather and much lower temperatures than in Ireland, where you might be at -10 or 15, and while the house is unoccupied, you can reduce the airflow through the house and maximize the energy efficiency of an MVHR unit. But to be honest, the cost of doing that, and you'd have to have an agreement cert in order to do that. And because of our climate, I just don't think it's necessary to modulate and go down below the minimum flow rates in Ireland, if that makes sense, because your losses are minimum anyway, and we don't have the extreme temperatures.
Yeah, fair enough. Patrick asks, how does the DCV work in a single-story vaulted ceiling? Would this be individual wall vents, small cottage type building? There's no attic area.
Again, to meet Part F, you need your background ventilators, you need your ventilation from your wet rooms. So typically in that scenario, you'd house the fan in a boxing above a utility room cupboard or inside a cupboard inside a kitchen, but you still need your mechanical electric ventilation from your wet rooms. Excuse me. You still need your background ventilators in your habitable spaces. So you still
I'm
need to do it.
imagining kind of an extension type scenario there, maybe in that question. So obviously you could put your vent through the wall if the vault ceiling into the existing building, and as you said,
Exactly. Yeah.
you'll often see a separate unit, as you described in your presentation, maybe running that isolated part of the house separately.
Yeah, look, we do a lot of warmer home schemes now. Again, they have to be air tightness tested, and once you go below 5, then you need mechanical electric ventilation. You see a lot of them would have a flat roof extension, maybe with a utility and a WC stuck on the back of the kitchen. Again, it can be tricky. You may have downstand beams that you can't get ducts through. So in that scenario, you'd stick in a second fan probably just to do the utility and the WC. Again, you see a lot of older buildings that would have your 2 up, 2 down. They might have no upstairs bathroom. You just have 2 bedrooms upstairs with no extract ventilation. And again, it's not a requirement under Part F, but we would often ask that mechanical extract would be installed on the first floor landing just to get some air movement, because background ventilation on its own isn't sufficient. You need the negative pressure of the extract to pull the air into the rooms.
Good. And Owen has a personal question here, I think. Owen, and it has an extract fan in 2 bathrooms that he didn't maintain properly. There was significant black mold build up in the fan, which I have cleaned off where reachable. What can get rid of the mold within the fan? Is there a way of replacement of the fan, and the duct above is required? This is worse in the ensuite. A small room they use for showers had a small rad but doesn't seem to ventilate properly. So what's the question in there? Is there a way of removing mold from the fan? Yeah.
Is it an intermittent fan or an MEV or a DCV?
Fan, yeah. I think it's the second one to try to deal with the problem, but it didn't seem to be working. But it mustn't be extracting properly, I guess.
It's a pretty good chance it's connected to kitchen extractor hood type flexible duct into his attic, uninsulated, so that the air is condensing once it hits the pipe, and probably not connected out properly. He'd probably want to look at how the extract fan is actually extracting out of his house. If it's uninsulated pipe, it will condense and it will drop back down, and there will always be moisture in that pipe. So he probably want to fix that before he, cleaning the fan may get rid of the mold that's on it. But if it's not extracting, it's not extracting.
It depends on the fan too. If it's an axial fan or a centrifugal fan, like an axial fan doesn't generate a huge amount of pressure. So even if the duct is insulated, it may not be able to push the air through this. I don't know what it is, but if it's an insulated flexible duct that's not pull taut, it doesn't have sufficient pressure to move the air all the way out. So again, it depends on the fan that's been used. So like axial fans, we wouldn't be recommending them anyway. There should be minimum centrifugal fans these days.
I'm pretty sure Owen, I know who it is there. He's quite experienced, and he's saying that it is flexible ducting and it is centrifugal. But I suppose on his point, is there a product or something that can be put through a duct that's to get rid of, to clean out the mold, or is there
not flexible ducting anyway? You can get brushes and stuff to clean ducting, but it's probably cheaper just to replace it.
Elbow grease basically is what it needs to do.
Just replace it. You can buy a box of ducting for 50 quid. Yeah.
I think we have two we can join together here, Colm and Liam. Colm's wondering about he likes your spreadsheet, Tony, and is wondering, do you make it available for your ventilation calculations? And Liam was wondering about the VOCs. Is there a breakdown where they come from within the building? Like, what's the worst VOC? Where does most of it come from, I guess?
Well, yeah, if you told me if you want, just send me a mail. I'll send you back the Excel spreadsheet. It's just something I put together to get myself. It's pretty handy, and you can play with it. You can change it if you want. Regarding VOCs, like everything has VOCs now. Everything that's glued and manufactured, unless it's a totally natural product, is emitting VOCs. From your flooring, your paint, even and again, I think. Well, speaking about paint, there's a lot of new products coming on the line with VOC free paint, and there seems to be VOC cleaning products, and if you go into healthcare shops, there's a lot of stuff now that is reducing the VOCs in your house, and it does make a big difference to the house. I came across it recently at a school conference in the UK where they changed the cleaning products that they were mopping the floor with the VOC free, and it improved the air quality in the school dramatically. So you can make changes and help reduce the VOCs by what you use, the cleaning products and sprays that you use within the house.
You mentioned the printer there as a particular offender for creating VOCs. Maybe John, would you have one or two last ones there? Any of the standout questions there you want to throw out?
Okay, I'll just go through a few that came in there recently. So let's see. Start here.
Does everybody do one or two? Because I think yeah, we're going way over.
Okay. Let's see. Sorry, now just see what happened here. Someone's just discussion here actually. In a well-insulated, this is from John. In a well-insulated, airtight retrofit, is DC MEV actually preferable to MVHR? No maintenance, etc. A bit like people not bothering with the heat pumps in highly insulated houses.
Look, like MVHR always
Personal choice.
MVHR always trumps any form of standard MEV or DCV, because like you're filtering the air, you're tempering the air, but it's all down to budget, and space and how easy. Like retrofit can be difficult for MVHR, it can be. So if the budget's there and the space is there, MVHR would be the go-to. Failing that, DCV would be the next choice.
Okay.
In my opinion.
And from Donald there, regarding demand control ventilation in apartments where the kitchen extract is not extracted externally and is replaced with a charcoal filter, is this practice allowed with demand control ventilation?
Yes.
I've come across apartments where the demand control units are becoming damaged with fats or grease. Again,
if there's like charcoal filters and grease filters should be directly above the hob. They should be used when cooking, even if it's recirculating. We don't recommend DCV extract grills be located near cookers. They should be using the recirculating hood for that purpose, for remove grease. But saying that, there are filters that you can get for the DCV extract units that incorporate a grease filter. But again, they should be using the recirculating hood for its purpose, which is to remove grease primarily. Yeah. There are charcoal filters for odor, but again, they last a year or two and then they're never reactivated or replaced. So it's just a grease filter.
Okay. And I'll go one more there. Just do you offer a solution or a recommended approach for monitoring indoor air quality, either integrated with your ventilation systems or a standalone option?
You can buy indoor air quality meters there online, or Amazon, or I think even Lidl had one there recently. You can just stick them and move them from room to room, check your indoor air quality. There isn't one really integrated into the system. I always find it's kind of interesting trying to integrate an indoor air quality unit into a system where you're kind of adding all the rooms together and giving the average. To me, isn't accurate. You're better off moving a single room monitor around, checking it that way. Just my opinion.
I suppose in terms of DCV, like the only sensor we have is the humidity sensor. We don't do CO2 or VOC or any of those types of sensors. So short answer is no. But that's what the argument cert was for. It checked the CO2, it checked the VOCs with the modulating system, and that's why it took so long. Is we had to show that even by reducing the ventilation rate, that the indoor air quality still at least meets the same as what's already approved in Part F.
Very good. I think that's the most of the questions there now. Anyway.
Thanks, John. That's great. And just to reiterate, people are sticking their full names on the chat there, which is great to make sure we can get the CPD points out, which we'll do. So yeah, just to thank Tony and Colin very much. That was really entertaining, really informative, I should say, as well as entertaining. So thanks again, and thanks for all our members for tuning in this morning. And we'll be back on the 4th of December for another one on PV. So hopefully keep an eye on your inboxes for that. So thanks again.
Okay,
Thanks very
again,
much.
I'll try and answer some of those
Thank you.
questions that appeared online, and there's
Okay,
some
we'll
chat
leave that open
I
there
can
if you
still
want to.
go through.
Just aware, lots of people are probably heading off.
Yeah.
Okay.
A certain amount of it was discussion anyway, I think so, yeah.
So will you put a list together of the email addresses and stuff for the CPDs points? And
Yeah.
See
We'll do that.
all these notifications coming up here.
Yeah. Oh no, we'll put that all together. Barbara,
Perfect.
well, Barbara will. When I say we, put all that together. I'm sure we probably have. You know, you needed your name and address and email address to sign in, so I guess there's probably a database there where that can happen simply. But we will get that to you, no problem.
Very good.
Will I stop recording?
Please, Barbara. Yeah.
Okay, that will probably, yeah, as long as it doesn't knock us all off now.
Yeah, we had 197 at the
Very
height
good.
there, guys.